thanks for coming in. So, as I said, my name is Ali. I give a little brief of myself, and then we can jump into the class. I think I'm teaching today and tomorrow, and then after that, we'll have a little more dive deep into the tech side, which my colleagues will teach. My role is I'm a partner at 7Gate Ventures, which 7Gate Academy is part of that. 7Gate Ventures invests in early stage startups. I've been investing for the past 3 years, for actually 4 years now, since 2015. And I personally got to crypto around 2013 by reading a Bitcoin white paper. A friend of mine sent it to me, and I got excited, and I kind of went to a rabbit hole. I've been investing in this space in crypto for the past 2 years as part of a separate fund. So we spend a lot of time understanding different chains, how they can add value, and where we can provide value to the companies. Today I'll kind of go overall on the subject, stay a little high level. Now I'm going to go in depth, and then in the next day I'll kind of teach you guys how to set up wallets, how you can acquire assets of Bitcoin, Ethereum, how you can set up private key, public key, how you can send Bitcoin, Ethereum to each other. That could be probably on the test net or the main net, so we can kind of get a feeling of how the practically works. But today we kind of stay on top, so high level. We need to take a break at 7. I have a call I have to take for like 30 minutes, so I'm gonna cut it like probably 6:50 or something to give me enough time. Ask me if you have any questions, so I want to make it dynamic. If you have any questions, jump in. Don't wait till the end of the presentation, just ask me anything you want. So everything started 2008 when like a pseudonymous person dropped a paper on peer-to-peer. Yeah.
Sorry. Will we get access to these slides?
Yes. I think you already signed up for Slack, right? Mm-hmm. So I'll post the slides, so you don't need to take a note on the slides. I'll post it to Slack so everyone has access to it. So 2008, a white paper was posted by a pseudonymous person called Nakamoto, and the paper basically lay out that there's a new way of sending electronic payments to each other without central entity. And that was really a breakthrough because before that, there was no decentralized systems that you can send money to somebody else over the internet. You always had to use a central entity. And the reason for that was a double spending problem. So let me explain that. What's a double spending problem? So if I give you something in the physical world, right? So if I give you this cup, right? You have it. You have a custody that I don't have. It's only one object, right? There's no second version of it. It's only one, right? But in digital format, there was no way of making sure you have one single copy of a file, right? So if I send you a JPEG file, you wouldn't know I have a 10,000 copy in my machine, right? I could make a lot of copies and you wouldn't show, right? So if I send you money, you wouldn't know I have another version of it, right? So you had to use services like PayPal or Stripe or services to make sure that there is a central company that says, okay, well, Ali sent money from his account to Bob's account, and it's not his account again. So there was a central entity like making sure that there's no double spending. It was pretty much impossible to do it in peer-to-peer fashion. It's like, hey, I'll send it to you, and then I don't have it anymore. So basically, what Bitcoin white paper said is that, hey, there's a new method of making sure that a value move from Ali to Bob without third person, and Ali doesn't have the custody, and that was really a breakthrough. The Bitcoin basically was an application of fundamental architecture, which we call a blockchain. So if you read a Bitcoin white paper, it's a very easy paper to read. It's like around 9 pages. Doesn't actually have the word blockchain in it. The blockchain is a word that people gave it to it. But basically means that it's a set of, do you guys know hash map? Hash tables, hash map. It's basically set of tables. It's easier for me, maybe I don't have a pen to draw over there. So think of it as a set of blocks that everything is linked. It's like a linked list, linked to each other, right? And the way it's said is like this database is distributed, so it's across multiple pairs, and it's decentralized. That means there's no central entity controlling it, and it's like a accounting ledger, right? So think of it as an Excel sheet, right? So in an Excel sheet, you can have Ali has $10, Bob has $10, and then when I send $1 to Bob have 11 and I have 9, right? That's one copy. Imagine that you have a lot of copies of that, a lot of pairs having this, having that, and then when a new transaction comes in, all the Excel sheets get updated. So everyone's Excel sheet get updated. There was a new method was introduced that making sure everyone is in sync. Same as torrent. So if you know torrent, when you see the network, everyone get the same copy, right? But this is just for values rather than files. In order to do that, introduce a new method called proof of work. So proof of work, which I'll go into it makes sure that everyone has the latest version of the ledger. Okay, so people get confused between distributed and decentralized. So I'm going to briefly talk about what's different stuff. So distributed, so Google, Amazon, Facebook, any company pretty much is distributed, right? What does that mean? Google doesn't have one server, right? It has gazillion servers. It has in Washington, in San Francisco, in London, in Hong Kong. So if one server goes down, Google doesn't go down, right? So they have multiple versions running different servers, different regions. So make sure you cover. So for example, if I hit Google, I don't hit the servers in Hong Kong, right? I'll probably hit the servers in California. Same, like if people browse Google from, I don't know, London, they don't hit the California servers, they hit the Europe servers. So it's distributed, right? But it's not decentralized. What does that mean? So that means there's a central company owns all these servers. Decentralized, on the other hand, means that there is not a central company or there's not a central entity controlling this these servers. So they are acting on themselves. So that's the difference between decentralized and distributed. So PayPal is distributed. So that means that they have a lot of servers around the world, but they are a central company that can control your money. If, for example, law enforcement goes to PayPal and say, hey, you know what? Ali has X amount of dollars in the PayPal account, you need to shut it down, they will shut it down, right? So they have control over my account. What Bitcoin's trying to do was that, hey, you know what, we want to remove that middle layer and say, hey, you own your own asset, you own your own money, and there's nobody that can take it over. Okay, so what happened? So let's talk about ledger. So I said blockchain is a distributed, decentralized ledger. So ledger is just basically, as I mentioned before, it's like an Excel sheet, has a bunch of cells and it says who owns what. Nothing else. Ali owns 10, Bob owns 10, and then what happened after that. So in this case, again, what blockchain is trying to do is that create this ledger, make it decentralized, so each pair has its own version, and we have a lot of copies around the world. So if one goes down, there's another version that exists in the world. I briefly talked about that. So I want to talk a little about this. So the biggest value of the blockchain and what it solved was double spending. The way it does it is apparently, let me get a pen so I can draw it here. Yeah, so I'm going to draw it here. So the way it works is that, say it says Ali 10, Bob 10, right? So this is one cell, right? So one Excel sheet has this information. The next one is that Ali sends 1 to Bob, so Ali has 9 and Bob has 11, right? This is a normal database. If you guys obviously in data software engineers, you will know it. And PayPal is a central company, has this information, right? Is distributed, says all the servers, but the company owns it. So he says, hey, Ali, you know what? For some reasons, we want to block your account so they can remove that, right? Can we wipe that? But if you can decentralize, so that means you have a lot of computers have complete record of this. So they have complete record. So if this goes down, 2 other computers have it. If the other one goes down, there's one that still has a full record. The tough part was that every time there's a new one, so then after that, I don't know, Ali sends another one, so Ali has 8, and then Bob has 12. making sure that every computer, so then we have another computer here, can sync up. So then has a latest record, this one has a latest record, and this one has a latest record, right? So that was the challenging part. The way it does it is this way. But creating an append-only ledger, which it's like this. So think of it as a block, right? So we have one block. It started from nothing. So there was the first transaction happen, and it says, I don't know, 2 BTC. So this system has its own native currency, so the network is called Bitcoin. The currency is called Bitcoin, which is small b. So the network is Bitcoin with capital B, the currency is Bitcoin. The another network is Ethereum, which is like a similar to Bitcoin, but its own currency is Ether. So the another network is Ethereum, but its currency is Ether. So Ether or BTC and Bitcoin is the one that you move around the system. So in here, you have a bunch of information. You have data, you have hash, and you have hash of previous block. So the genesis block is the name of a block that was first created, right? There is no history before it, right? This has all the information about the state of the blockchain, right? The ledger. So think of it as all the accounting that exists. Once a new transaction happens, it creates a new block. You can never go back. You can always go forward. So it's append only. You think of it as a database that doesn't have a delete. You can always add to it, right? This block, and each block has a hash, SH 256, right? This one has a hash of the previous block. So this one has some hash, this one has hash. This one has a hash of the previous one. And it keeps going, right? So it's like a linked list. So you can always go back and see the history of the transactions. So you can follow the money. So when people say Bitcoin is anonymous, well actually, it's anonymous in terms of you don't know who owns what, but you can see all the transactions in a database. It's very transparent. So Bitcoin network is actually very transparent, but it is pseudonymous, so you don't know who owns what, but you can see all the money moving around, right? Is it clear what I'm saying? Yeah? Okay. So what's hard about it is it's extremely easy to verify the previous block because you can see the hash of this and you can see hash of that. But it's extremely hard to go back and generate because let's say there's a bunch of transactions happening, right? So I had 10 and then I move 9, 11 and this all come here. At this point I have, I don't know, Ali has 2 and then Bob is what, 20, 22, right? And there's all the records here. In order for me to change this one, the reason I'm saying Bitcoin is very secure because in order for me to change the history of it, I have to go back and recalculate every block because every block has a hash of the previous one. If the data changes in this block, it produces different hash number, and that produces different hash here and a different hash here. So then it's extremely hard to go back to do it. It's possible to do it with a 51% attack. What is 51% attack? Let's go 51% attack. 51% attack means when you take over 51% of the network. So Bitcoin networks or any decentralized network looks something like this. Like let's say all these computers are connected and then you have another one, then it connects to this. So it's all connected, right? What I said in this case, all of this have a complete record of the ledger, Bitcoin ledger, right? So if this one goes out, you have complete count, right? In order for me to change the records, and this is, by the way, is a linked list of all the blocks, right? So this ledger, it points to the latest one, so you can see the latest record, but it's all the blocks before it, right? In order for me to change records, say, hey, I want to change my history, my balance, if I have control over the 51% of network, so over 50% of the network, if I own these 3 machines, I can change the record, right? Because it's very easy for me to do. So in order to have a really robust network, you have to have huge computers. And not each company owns, or entity owns more than 51%. If I have 49% of the network, I cannot take it over because it will be very expensive to do. Is it clear? The other interesting part is, if I want to have 51% attack, let's say we have 10,000 computers, right? 10,000 computers, right? Could be mainframes or whatever it is, right? In order to have 51% attack, I cannot add new machines to the system, because if I add new machines to the system, I'm going to increase the complexity of the system, right? So it's going to become even more expensive to do. What I have to do, I have to acquire the existing computers, not adding it. Clear? Cool. Yeah, so this is what I mean. Like every block, so this is block one, so Genesis block is when it was created. There was no history. You can actually go back on Bitcoin network, and you can see when was the first one created. It is time stamped, and it's easy to can verify. And then after that, every block links to the previous one, and you can see the coins being created. Every time a new transaction happens, a new BTC is created. Bitcoin, which is a BTC, which is the symbol for Bitcoin, is capped at 21 million. So its average is going to be 21 million Bitcoin. It's inflationary. Yeah. Okay. Do you have any questions regarding this before I move to a similar? I want to compare the new network to Bitcoin. No questions? Cool. So Ethereum, so Bitcoin, it's obviously it's not simple. It's fairly simple in terms of it's just a value transfer. There's nothing more. It's just an Excel sheet, has account and then value. So this account, which is think of it as a wallet or a bank account, says, hey, this account has 2 BTC, right? This account has 3 BTC. And then you can move 2 BTC here, and then this one will become 0. Account 1 has 0 BTC. Account 2, and it says 5 BTC, right? So you can go back in history and look at it. That's pretty much it. Obviously, it's a lot more complicated in terms of technical. I'm going to walk you through it, but that's pretty much it. You can't do anything more with it, right? Another network was born by someone called Vitalik, which is called Ethereum. It says, hey, well, can we have decentralized applications? The idea was that when you write application, right, any software, it runs a computer or runs in a server, right? But it still owns by a central company, right? So if the software runs in a computer, I decide to shut down my computer, software stops working, right? If I run it in AWS, in Amazon potentially can close the server, right? Or, I don't know, US sanctions my website, can take down my software, right? So the idea was that can we have a Turing complete language that actually is not Turing, it's Turing complete language for this network. So you can write like if statements, and that was the idea. So Ethereum was born. Ethereum basically creates decentralized network that you can have conditional software. So think of it as this very simple idea is this: a vending machine, right? That's everyone uses. Vending machine, you put $2 and it says, hey, well, if $2 was given to me, I'm gonna drop this can, right? So this Pepsi, right? So Ethereum creates this platform that you can say, hey, you know what? They call it smart contract. Think of it as a conditional statement, right? Say, hey, if these parameters was given, execute this output, right? And the way it does it is these computers are hosting, instead of the ledger, are hosting this this smart contract or this program. Think of it, right? And it's event driven. As soon as something happens, they trigger it and the program runs. So in order to shut down the server, you have to shut down every computer. Otherwise, it's decentralized. Any computer can do it. So if I connect my computer to Ethereum, you connect your computer to Ethereum, then all of us runs that software. So no one can take that software down, right? So let's say we run auction, right? And if someone decides, hey, this is illegal auction, we cannot, run it in US or whatever, UK, no one can take it down because you don't know who runs this software now. It's not like Amazon runs it or you run it or a specific center. And that's the idea about it, right? So a currency for running this network called Ether. You had BTC here, you have Ether here. So what is Ether? It is basically used for gas. Okay, what is gas? In order each computer to run this software, it requires the resources, right? I'm gonna have CPU, I'm gonna have memory, it's gonna cost me money to do it, right? So these companies say, hey, well, I will run your software, but I wanna get paid. You're taking my resource, I wanna get paid. So then these computers getting paid Ether to run a computer, to run the software. If the software is very complex, the gas price it's a lot more. So you say, hey, pay me more, I will run it. Got it? So I'm gonna walk into it, so explain. So that was the idea of Ether, right? So that's a very generalized, and there's a bunch of applications being built, which we'll walk into it. But there's a new idea was kind of born with this decentralized networks. This guy, Joel from a venture capital USV, kind of introduced this idea. It's called FAB protocol. Have you guys heard about it? No? Okay, so FAB protocol, the idea is that yeah. So when the internet was born, we have a bunch of protocols, right? So we have HTTP, SMTP, FTP, these protocols, right? So these are the fundamental protocols that runs the internet. So SMTP for mail, HTTP for browsing, HTTPS for secure website, and FTP for file transfer. So these are hasn't changed for the past, 10, 20 years. And the people who work for open source, they didn't really get paid, they did it for favor, and they were like, well, you're not paying us, we're not developing that much, it's only very niche people working on it. The value of the internet got captured by application companies. Application companies are what? Google, Facebook, Amazon, and so on, Microsoft, whatever. So these are the companies are built on top of these raw protocols, right? They are built on HTTP, they are built on SMTP, they're built on SMTP. But they are protecting, so they are worth billions of dollars, but it's not really contributing to this open source protocol, right? And it's centralized again, whatever Facebook controls, it owns your data. You cannot really leave, it's over there. What's a new idea is that, hey, you know what? Let's decentralize this. Let's decentralize the internet. Rather than only a few companies own your data and capturing a value, how about we open it up like everybody else? If you want to create on HTTP, you can go ahead and create anything you want on HTTP. No one stops you, right? But if you build something on Facebook, I don't know if you guys build anything on Facebook, if they don't like you, they can stop your SDK. Or if you make so much money, they're like, hey, what is this business? They can copy it and launch it themselves, right? So it's very essential. It's there's a huge problem with LinkedIn that a lot of companies went and built a bunch of stuff on LinkedIn, right? They use the contact list on LinkedIn, and LinkedIn's wow, they kind of replicating LinkedIn, and they stop everyone. They stop everyone, and they kill all the companies, and these companies are multi-million, and they're like, hey, SDKs are removed, and all the companies literally shut down overnight, right? Which you cannot do that on HTTP. So I think the new era started, and the new era is this, which flipped this model. The idea is that you would have a fat protocol, so this is protocol, and then you have thin application layer. So what does a fat protocol mean? So in this case, think of it as you build these pipes that anyone can build applications. As I said, it's called decentralized application, and doesn't rely on a specific company. So what does that mean? So storage. I'm going to walk you through a few examples down the slides, but storage. If you want to store something now, what are your options on the cloud? So you store it on Dropbox, you store it on Box, you store it on Amazon S3. There's a bunch of solutions, right? But they're all centralized. That means those companies can say, you know what, we actually, if you store anything on Dropbox, by default, they own your photos. They can do anything with your photos. They're not doing it because it would be bad for marketing, but they own your data, own your photos. So how about you have a decentralized storage? So that means you can store your files in everyone's computer, but that means by sharding it, you divide it to small pieces, you encrypt it, no one can see it, you store it in different places, and think of it as HTTP. So you store this in this protocol and technical way and in everyone's computer. And then you can create an application layer on top of it. That means that will be interface. So then you have maybe different way of representing that. And another example would be torrent, right? So torrent is a protocol, right? But you can have a lot of different sites displaying that what files been stored in torrent, right? Or how been downloading it. So I think the world is going towards that. I think the value is moving to decentralized. So a lot of protocols that we need is gonna get decentralized. A lot of value is gonna get captured here, and the display and the UI is gonna get really thin. And I'll walk through examples. So that's the idea about fat protocols, and a lot of companies are working towards that. And it's, you have a question? Okay, one second.
Sure.
So, and in order to get there, Ethereum is the first platform enables, and now we have a lot of competing platforms. We'll walk through it, but it's because in order to create those protocols, you can have decentralized network that enables you to write any software you want. By that you deploy your software in this network, and it's been running on so many different machines. And machines could be a watch, could be mainframes, could be TV. You don't know what it is, as long as you can compute that.
I was just saying, I think naively you'd assume that protocols don't get developed that much because it takes all these computer scientists all these years to develop them. So what makes you hopeful that the future of the protocol, everyone can just develop protocols all the time?
Yeah. So that's a good point. I don't think people not working on protocols because it's very hard to do. I think there's no incentives. So how much do you get paid to work on an SSH? Tiny. There's a foundation is paying you, I don't know, I'm just making it up, $50K. But you can work on Facebook, get $300K. So why would you want to work on SSH? You need to really love open source and do it for favor, right? So I think there's a lot of smart people, but they're not they're not being paid to work on open source network. So I'm gonna walk you through how you're gonna get incentivized to work in these protocols, what's the currency of it and why people are excited about it. But I think there is a new business model for open source. So people moving from closed network Facebook, Google, all these centralized companies to open source and creating a new model of doing it. And that's why I think I'm very excited about it. Any questions? Okay, so this is an example. Oh, you can't really see it. But I try to explain to you. Okay. So let me talk about a few examples of this, right? So I'm going to talk about two examples. So one is storage, and then one is another computation. Okay, storage. So we have a lot of idle storage in our world, right? So your laptop, you're not using 100% of your storage. You might use 20%, 50%. My Apple Watch, I have storage, I'm using probably 20% of it, right? TV has storage, no one using it, it's idle. Would it not be better if we leverage this storage and actually make money out of it? we rent it out. So basically, we rent our resources, our scarce resources. But why would I want to rent it out if I'm not getting paid? So there's a new model that pay me for it. Let me step back. People use torrent, right? So everyone uses torrent. Well, not everyone who's recording. It's people. Some people use torrent to download movies, right? But rarely people seed it. You download it, you remove it. You're not really seeding it to network. Why? Because there's no benefit for you. You share your bandwidth, and there's no, there's extra cost because you have paying for that bandwidth, right? So what this network allows you is that, hey, you know what? There's a bunch of computers, and it's decentralized. Everyone is connected to everyone, somehow. And say, hey, you know what? There is this file, let's say for JPEG for now, make it simple. If you guys store this, take it divided by a gazillion times, you encrypt it so no one can see it, and you store every piece in different computers. For storing this, I'm gonna pay you. The networks pay you X amount of token, right? So I'm gonna make it some name, XP token, right? So for 5 megabyte, if you store, I'm gonna pay you 5 XP. So what can I do with that 5 XP? Well, because they're digital and it's easy to transfer, I can transfer my 5 XP to get BTC, Bitcoin, or I can get Ether, or I can even exchange it for dollar, what I want. But basically, I'm getting paid for the fixed resource I have. So I think that's a very interesting. It opens up a lot of opportunities, right? Another way is computational. But if I go to computational, storage. So there is again, you can't see it here, but let me see if I can. My computer looks better, so let me see if I find it. Here. Okay, here. So there's that many companies working it. There's Filecoin, Storage, SIA, there's Fuse. So there's these networks that are actually live now. You can go and use it. You download their software on your computer, or it can be on your phone. Well, phone is not there yet, but on mainframes, whatever it is, right? And you say, hey, you know what? I'm gonna allocate 10% of my storage, my computer, or my TV, whatever it is, to this network. And as people store files, again, you can't see their files because they're encrypted. You get paid their currency. What is the currency? The way it works is that this is Ethereum blockchain. So think of it as the fundamental layer. And there's a network on top of it, which is this case, let's say, storage. It writes like this. And it has its own native currency, right? I don't know what the native is, but let's say, I'll give you another one. It's a SIA network, which the token is SIA, right? So you say, hey, for every, I'm just making up, I don't know the exact number. For every 100 megabyte, you're gonna own, 10 SIA. So as people store files in my computer and I can see it's taking spaces, I'm gonna earn SIA. What can I do with SIA? You can spend SIA back to the network. So you say, hey, now I want to store things in your computers. So you can spend SIA on the network and get access to the network. Think of it as a private key. So you can spend that to get access to storage. Or, because they're very easy transferable, they're digital tokens, you can transfer SIA for any other tokens you want. So Bitcoin for moving money around, or Ethereum to running applications. Or if you want to, I'll walk you through it. So there's few networks creating that. The another idea is computational. So if you want to run the software again, you run it on your computer, on an EC2 or whatever, right? But what about if you want to run in decentralized way, right? Ethereum creates that network and a programming language to do it. But there's another one called what's the name? Golem. Here, Golem. It allows you to run, for example, graphic rendering on anyone's computer. So say, hey, I'm not using my CPU 100%, and I want to allocate 30% of my CPU for people. So people who want to do render, let's say AutoCAD or Photoshop, very complex rendering, and they don't have access to that much CPU. They had to go to run it in AWS. Now they can run it in decentralized way. Why do they want to do it? First, it's cheaper. It's way cheaper to run in this network than in AWS or Microsoft Azure or a few others. And also, like, it's not censored, right? I mean, I'm not talking about rendering because it's fairly simple to do, but let's think about it in the future, right? So a lot of things you want to run in a decentralized way, you don't want to run in a centralized way, and you don't want people to control your data. And that's what we do it. So Golem is another one. Make sense? So now think about it as a lot of different opportunities opening up. So a lot of people now creating a lot of different decentralized applications. It's called decentralized application or DEX, and they tackle it a different way. So we have KYC AML. So you know what, you want to make sure that you know, in America, if you want to do KYC AML, there's few companies doing it, right? So now you can write in decentralized way. So they look at the social network, they look at a bunch of stuff, and no one owns your data. The network owns your data, and that's just another way of doing it. So
and KYC is know
your customer. Yeah. So like, let's say you want to open a bank account or want to create a social credit score. There's only like 2 companies in the US doing it. But how about? Okay, let me walk through this easy. Okay, this is one I'm actually really excited. So, enjoy. I'm terrible graph here. So that's me. This is Facebook, Google, Amazon, Microsoft. Who am I missing? I don't know. Netflix. All these guys have a copy of my information, right? They have my name, my password, my social security number, my home address, my credit card information. Everyone have their copy, right? They're not sharing with each other, right? So every time I go to a new company, I have to create one new one. I have to create a new account, right? And I mean, every day one of them is getting hacked. So they get breached, right? So there's gazillion copies of my information, and everyone says they're protecting it, but you know, I mean, these are huge companies, but think about it as a lot of smaller companies not protecting the databases, getting hacked all the time, right? So now let's think about how this can be happening in a decentralized way, or how can we own our data? So I think this is getting flipped. What does that mean? So again, this is me as a beautiful person. These are the companies. And I think what happens is I'm gonna have my data here, and everyone is gonna point to this. So Facebook, Google, Amazon, I'm just giving big names by the way, there's a lot of small ones, Microsoft. So here, think of it as I'm gonna have my data, my information as name, social security number, address, email address, a bunch of stuff, right? And every time I want to access a service, Facebook say, hey, I only need your name. You know, I can say proof. You can only see my name rather than I give you everything. And then these are being verified maybe by third party and is only sitting on one small place, but again, decentralized and distributed cross network. But then every time someone wants to access it, I say, sure, you can read it. You don't need to copy it and store it yourself. You can just access it. So that's what I mean by KYC, know your customer. So I have custody of my data, and whoever wants to access it, I have to prove it and give them permission to read it. Right? So I think that's the world we're talking about. By the way, all these requests and access are smart contract, but that means it's a protocol that's automatically being run. Any questions?
In this scenario, who's paying the gas to access your data?
So there's a company called Civic, which you guys should look into it, if I can find it. Civic identity. Here, Civic. Okay, Civic is basically trying to do this. What it is that it has, I need to remember, I have to go back and look at it, but it's basically me as a person. There is provider, there is a KYC provider, and there's another one, right? So basically, there's one company that verifies who I am, by kind of proving my passport and a few other stuff. There's a company vendor, I think it's called, that wants to get that access, right? So this company pays this company in its own native currency, which is a CVC. CVC is a token for Civic. And this company get paid CVC. So in order for this closed network to work, they have to transact in CVC, right? That's how they work. So instead of paying US dollar for each other, they can say, and every time, for example, someone wants to read my information, have to give me CVC, then I will unlock it. I have to look in details, but basically it's like 3 or 4 players, and in order that network to function, everyone has to use CVC. And see what is CVC? CVC is just running that smart contract, right? So in order to perform a request or access or something like that. Basically, you're paying for the private key or API code if you think about it.
Right.
You're creating a macro economy. It's an economy basically. So the whole point of this blockchain is that you're combining finance, economy, and technology together, right? So in order to function, people need to get paid, and in order to get paid, get paid in CVC. What does a person can do with CVC? Well, first of all, why do you want to use this over a traditional one? Because this is actually cheaper. Because your data is saved once rather than creating it few times. So it's way cheaper to access this than the traditional way. And the person can use the CVC to spend it back to the network or can change it for another currency that they want to.
And so I guess the network overhead of hopping between these different service providers, it like pales in comparison to like having to copy that data a bunch of times.
Exactly. Well, now it's really beginning. So obviously the overhead it's expensive because you need to have first movers to using it. But the idea is that over time, all these ports are kind of hooked to each other, so it's very easy transferable. But yeah. Cool. I want to introduce you. Have you heard of initial token offering? Yeah. So I'm going to briefly talk about it. So the idea is that I'm a venture capitalist and I invest in startups. Before, if you want to start a company, you say, hey, I want to have an idea that be a next billion-dollar company like Facebook. Give me X amount of dollars, and say, oh, what's the idea is? And we give you money, you go build a company, right? But if you came and say, hey, you know what, I want to build an open source project, and I'm like, yeah, I don't know if I want to give you money. What's the return for me? What's the incentives? People will do it, but they do it as a charity. They're not really doing it for capital returns. So the initial token offering, now is a lot of scams out there. So I'm trying to use the idea of it, not just go ahead and do it. I think it's going to get better over time. The idea is that you don't need to get permissions to raise capital. It's like crowdsource, right? The way you would do it is that, hey, you know what? I want to create a new network. And the network would enable decentralized storage, right? And just make it up easy. In order to do that, I'm going to create X amount of tokens. In order to function to work, we need 1 billion tokens, and they are fractional, right? Because you can have a lot of smaller versions, right? In order to do that, it's going to have a fixed amount of tokens, and I'm going to allocate 10% to my initial users. In order for me to bootstrap a network, I need to raise $2 million, right? So I'm going to raise $2 million, right? And I'm going to give you the tokens for this amount. So the way it works is that you write a smart contract, think of it as autonomous company, right? So there is a wallet that you send your ETH. So Ethereum network has this ETH as a currency. You send 5 ETH to this, and automatically it sends you back, 10 X token, right? And X token is a native currency of this network to function. So that's the initial coin offering, is that, hey, I'm creating a new network that the purpose of this network to do one specific task, right? And in order for me to do it, I need capital to develop it, right? So you open it to anyone in the world. So it's just basically disrupting venture capitalists. You don't need to go and knock doors, hey, I want to build this idea, and help me out. You can raise from anyone in the world, and anyone can participate in the network. It started in 2016, it really ramped up 2017, like billions of dollars, I think $10-20 billion was raised, but a lot of companies around the world, again, a lot of us scam, so forget about most of them. but some of them are legitimate. A lot of interesting companies have been born about it. So it's just like, hey, this is my idea. I want to build it, and you can own a piece of this network, and you kind of bootstrap it. In order for these networks to work, the amazing part of Bitcoin is that it's naturally bootstrapped by the network, right? So you need to believe in it in order to work. There was one computer first, which is the founder, the anonymous person, and the second person added his computer and they moved to Bitcoin, right? So one idea of initial coin offering is that you can hack the bootstrap, right? So it's like, hey, you know what? In order for me to bootstrap this network, I need people to participate, right? So that's why we say, hey, you know what? You guys invest and you can be the first users of it, right? Think of it as, Uber wants to start. If no one participates in the network, Uber wouldn't exist. If there's no driver or there is no rider, then it wouldn't work. So one of the interesting about initial coin offering is that they say, hey, guys, invest in the network and you can help bootstrap the network and kind of make it work.